Hello, math students. Welcome back to Module 3, Rational Numbers. Today's lesson is Lesson 4, and it's called Ordering Integers and Other Rational Numbers. Our goal for today we will work with ordering rational numbers. Just a quick reminder that integers are actually under the category of rational numbers because rational numbers definition is any number that can be written as a fraction. And all positive and negative numbers, which is what integers are, can be written as fractions. So remembering what integers and rational numbers are. So today our focus, again, like I said, was to learn how to order them. And ordering numbers basically means that you put them in order from least to greatest or from greatest to least, depending on what it asks you to do. The question in this lesson that I want you to think about is, how do you determine how to order rational numbers? So hopefully by the end of today's lesson, you'll be able to answer that. So on the things to know information, we are going to be focusing on some vocabulary words. I have a feeling that this is a review for a lot of you, but some of you it may be new information, so we're going to go ahead and look at it. The first word that I want to talk about is greater than. Greater than is a description of a number that has a larger value than another number. And we have a symbol in math that we use to describe greater than, and the symbol looks like this. And one of the ways that I like to remember how to tell the difference between a greater than symbol and a less than symbol is by using your hands. So a lot of you use your hands to count, a lot of you use your hands as manipulatives, which in my opinion is a brilliant idea. And so one of the things that even at 41 years old I do is I use my hands to help me figure out which one is which. Greater than starts with a G, and I have two hands. One of my hands is my left hand, and it looks like this, and one of my hands is my right hand, and it looks like this. And so what I do with using my hands to help me figure out is left hand starts with an L. So if I put all my fingers down except for these two fingers, I can make the letter L with my left hand. Well, if I remember that less than also starts with an L, and I turn my hand like this, then I've automatically made the less than symbol. So greater than is my right hand making a backwards L, or the greater than sign. So I make a backwards L and I cock it to the side a little bit, and now I have a greater than symbol. So the greater than symbol is on your right hand, and the less than symbol is on your left hand. And the way that you can remember which one is which is that less than starts with L. So this is less than, that's the way the direction of the less than symbol makes. Greater than, this is the direction that the greater than symbol makes because it's on your right hand. So again, the symbol for greater than looks like this. Right hand, turn it a little bit, and now you see the same symbol. Less than, which is the other vocabulary word that we have to pay attention to, is a description of a number that has a smaller value than another number. The symbol that we use for less than, again, looks like a capital L turned to the side. So capital L, turn to the side. Capital L, turn to the side. And it looks very similar to that symbol. Okay, so that's how I keep them straight, because a lot of kids get confused and have to have a tool to help them figure it out. And like I said, even at 41 years old, that little tool helps me. An inequality statement, boys and girls, this is very important because it's going to ask you to do this in many things. An inequality statement is a math sentence that uses these symbols to describe the numbers compared to each other. So right here, if you look at this, this says EX, what stands for example. EX is actually an example of an inequality statement. This is a number, this is a number, this is the actual inequality sign, but an inequality statement is this whole thing because it's making it a sentence. So 7 is greater than -3, and that is true. And the way we can prove it is by looking at the number line. So if I plot 7, remember that we always start at 0 and we go to our number. So over here is 7, right? So this is 7. Okay, and then if we plot -3, we start at 0 and go to -3, right? And this is -3. And if we look at both of these numbers, and remember, we're trying to determine how far away they are from 0. So negative 3 has 1, 2, 3 hops to 0, right? And 7 has 1, 2, 3, 4, 5, 6, 7 hops to 0, or away from 0. And it's going in the positive direction, so this means the number is getting bigger. This means the number is getting smaller. So this number is bigger than that number. And it's very easy to see that on the number line. So this is a true statement. 7 is greater than negative 3. So if we were trying to figure out what would be the inequality symbol that sits in here, you're looking at 7, you're looking at 3, and you're asking each other which one is bigger. 7 is greater than negative 3. Okay? So again, we have another example, and let's pretend that the sign is not there and you have to find it. So again, you're going to plot those two numbers. We're going to go to negative 9, which happens to start at 0. Go all the way over here because it fell off, so I'm going to extend my number line, and this right here will be negative 9. So this is where negative 9 sits. And then I'm going to negative 2, which happens to be right here. That's where negative 2 sits. And then we have to ask ourselves which one is bigger or smaller, and we can use the same technique we did before. Well, negative 2 is only 2 hops from 0, whereas negative 9 is actually 1, 2, 3, 4, 5, 6, 7, 8, 9 hops from 0 in the left direction. So it's going away from 0 on the left side, so it's getting smaller, 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 because remember in class we talked about the further away from 0 you go on the left, the smaller the number becomes. We now can see that negative 9 is smaller than negative 2 because negative 2 is only 2 hops away, whereas negative 9 is 9 hops away. So it's further away from 0 on the left, the smaller the number becomes. So this is tiny compared to this one. So negative 9 is less than negative 2. And we put the number line in there so that you guys can visually see the difference between the two numbers and then decide which is the correct inequality symbol to go in there. Okay? All right, so we're going back up to our goal for today. Today we will work with ordering numbers, ordering rational numbers, which we did. 7 is greater than 3, so if we were actually able to order them, we would say from least to greatest, it would go negative 3, and then it would go 7. That's from least to greatest, right? Oops, sorry, greatest. And then if we were doing least to greatest on this one, then we would say it goes negative 9 and then negative 2, going from least to greatest, because we just proved that negative 9 is smaller than negative 2. So in order, negative 3 to 7, in order, negative 9 to negative 2. And that's how you would write them in order. Okay? How do you determine how to order rational numbers? For me, the best way to do that is by putting them on the number line and seeing where they are. Okay? And then once you can actually visually see where they sit, that will tell you the order that they go from least to greatest. Remembering that 0 is the midpoint that has no value. And so you're trying to orient the numbers according to where they sit closest to 0. Okay? All right, kiddos, that's all I have for you in this lesson. I hope you learned a lot. Talk to you soon. Bye!